in statistics, the term variable is very important. Variables, it varies over time. And in the data collection or in the data table, you can see that like this, the form, the table, data table, you can see like this. Here, observation number 1, 2, 3, 4, 5, like that. Here, name, gender, age, and the district, like that. So the first observation, first of the name, Kumar. His gender is male, age 21, district Colombo district. Second, Anura, gender female, age 22, district Gambaha. And Vasanta, female, age 20, and district Kendi. Here, you see the name, it takes different values in different observation. These are the observation. Observation 1, observation 2, observation 3, like that. Gender, that it varies. And age, it also varies based on the observation. And the district also varies. So these are varies, no? So this called variable. Name is a variable. Gender is variable. Age is variable. A district is variable. Here, observation 1, 2, 3. These are the observations. Observation. The variable are changed throughout the observations. So these are the variables. In statistics, variable is any characteristics. Variable is any characteristics that may take a different value across individuals or units. For example, here it's a character name for an observation is an observation. Observation number 1 is an observation. Kumar is a name. It's a way, right? It's observation. The variable name is varies Kumar, Anura, Vasanta, and it describe Kumar, right? Kumara describe he's male and he's 21 years old. He's coming from Colombo district. It described, right? It's described. So in statistic, variable is any characteristic that can take a different values across individual units. Variables represent data. Variables represent data that is collected, measured, classified in a study and play a crucial role in organizing and understanding data. So this is the data set about a participant in a group, in an activities. In an activity, these are the participant, is a participant database. To classify, right? To make in organizing manner, this is a data set. To make the data set in well organized and well understandable manner, we need to organize the data set based on the variables. Variable name is a variable, gender is variable, age is a variable, and columns are variable. In that way, we have organized so that it make easy. A student survey, for example, we will take a student survey. This data set, right? This data set can have different types of variables. Some are quantitative variables. Quantitative age we can measure in terms of numbers: 25, 26, 27, 21, like that. A quantitative variable age. And height of the student: 180 centimeter, 140 centimeter, 165 centimeter. That we also number. Gender, it has no numerical value. It has different here. It has right? It has male or female, right? Male and female. So this is what? This is not in numerical term. So this is qualitative variable. It's a qualitative variable. And the major field of study. Some of you are studied commerce, some of you studied arts, some of science, some technology, mathematics, maths. Right? So this other field, it has no value. It has no numerical value. So these are called what? Qualitative. Right? Some variables can be measured in numbers, some are in aspects, non-numerical values. The primary classification of variables can be quantitative variable and qualitative variable. Quantitative variable and qualitative variable. Here, when we look at the quantitative variable, the nature, those are in numerical values. Those are numerical values representing count. It may be count or measurement. Count 1, 2, 3, 5, 6, 9, 20, 100,000, like that. Measurement like height 180 centimeter or 5.8 feet, and temperature like 38.5 Fahrenheit, sorry, Celsius, and 26.8 kilograms. Some measures and count. For example, age, how old are you? Revenue, how much revenue for this? Temperature, room temperature or body temperature. Number of items sold during the period of last month. These are the qualitative variable and qualitative. So this is quantitative numbers. So these are qualitative, right? Qualitative variables. It categorical values. So the categorical values representing labels or attributes. The label, observation 1, we put a label, Kumar. Your name is a label, right? Everybody of you having a name, no? That is a label of the object, the human object, a label. For attribute, say your attribute like gender, your gender, male or female. It's an attribute. It's not a label, it's an attribute. And your skin color is an attribute, right? So those are qualitative, no numerical values. Example, gender, product brand like Samsung, Apple, and Coca-Cola, right? Tesla, Toyota, this kind of things. And it has no numerical value. Country of origin, China, Sri Lanka, Nepal, like this. And major field of study like commerce and marketing, HR, accounting, finance or engineering, technology, science. So these are categories. Okay, so now you can understand the differences between quantitative variable and qualitative variable. Next we goes to classifying the variable, right? Again, we can further divide quantitative variables into two major types: discrete variable and continuous variable. Discrete and continuous. Discrete means full numbers. It has a full count. For example, number of employees, number of students, number of fruits, and the count. Mostly there comes the count. The continuous, it has some decimals, numbers, fractions, decimal like 0.25, 6.56, like this. So the decimals, fractions, 1/4, 2/5, like this. These are fractions. Right. Let's see. The discrete. So it has a full number 1, 2, 3, 10, 25, full number. A variable with countable, a distinct value. It has distinct value, countable 1, 2, 3, 4, like that. Distinct value. How many mangoes? How many heads? How many tails? Or how many, right? The number of, how many, in terms of numbers, like full numbers. How many computers? How many cables? Like that. A distinct number, it has a concrete number. It does not take half. Like how many students attend to this class? We could say 61 or 65, 102. But we cannot say today attendance is 60.5. Today attendance is number of employees in our company 522.35. We cannot say. So it should have a distinct value, full number. And it never take this kind of fractional values. These variables are whole numbers representing counts and cannot take fractional values. No, it does not. It never takes fractional values. So these are the fractional values. The number of employees, 25.5 or 20.5. We can write in this way as well. But we can't count in this way. So this kind of variable called discrete variable. When we look at the characteristics, the values are clear, distinct, and countable. Examples are number of employees in the department, 25 employees, 30 employees, like that. Number of items sold in a store, 10 items, 15 items. And number of customer complaints per day, 5 complaints, 12 complaints, like this. Number of votes, number of candidates, number of polling station, countable. And the continuous variable, a variable that can take any value, it will take any value within a specific range, including fractions and decimals. Can you say how many numbers between 1 to 5? Can you say how many numbers in between 1 to 5? 1 to 5? What are the values we can take? 1, 2, 3, 4, 5. Right? These are the full numbers. And we have infinitive numbers between them. 3.5, 2.67, 2.666667, 3.999991. Right? So there are different, we have infinitive number of infinite possibilities within the range. Right? So we can get infinitive numbers. These variables represent measurement, mostly height, weight, and temperature, like that. So characteristic values are not limited to whole numbers. Whole numbers mean just 1 or 2, 3, 4, not like that, right? It also include full number plus infinite possibilities within the range. Any values with decimals. See the examples in terms of business context. The time taken to complete a task. How many hours you have spent on this task to complete a task? One could say 1.25 hours. Another one could say 3.5 hours. Another one say 5 hours. Weight of the product, 15.2 kilograms, 3.5 grams, 1.2 milligrams. Room temperature, 22.4 degrees Celsius. Aspects here, the nature of aspect of the discrete variable. Discrete variable are countable, limited to whole number. And the continuous variables are measurable, not just count, measurable, can take any value within the range. Examples, number of books, family size, member of how many members in your family, employee count, how many employees in your department. Continuous variable, we have weight. What is your weight? Distances in kilometer or meter or centimeter. Time, temperature. So these are measures. These variables uh, mostly continuous variables. Data types. Data types. Earlier we talk about variable type. Variable type. So now we talk about data types. Data types. The foundation of statistical analysis. Without knowing the data type, it's very hard to deal with statistical analysis. Qualitative or categorical data and quantitative numerical data. First one is qualitative. I have explained a little now. Qualitative and quantitative. Quantitative expressed in terms of numbers, and the quantitative variables can be categorical. It has no numerical values. Characteristics here, the category qualitative variable means it represents characteristics or attributes that cannot be measured numerically, right? Represent names, label, categories. So these are what? Categories or labels. Your name is a label. Your gender is a category. Your field of study is a category, right? So it has no numerical values. And the data, right? For example, quantitative data represent measurable and calculable quantities. We can calculate. We can count the gender, how many female, how many male. We can count, but we can do some calculations, right? Female divided by male, right? Average gender. We can't do this kind of calculation, right? Expressed in terms of numbers, expressed in numbers suitable for mathematical operation. We can do all arithmetical operations. We can add, we can deduct, and we can divide, and we can multiply. We can do lot of operations. We can't say 20 female into 10 males. We can't do the calculations. Male into female, no, we can't. But we can do 20 kilograms divided by 5 kilograms. We can't, right? We can. So the kilograms, the weight, is measurable. And, right, it's very important. We can divide further the qualitative data, further subtypes. Numerical data. So, no, sorry, nominal data, some are ordinal data. Nominal data and ordinal data. Nominal data are categories without inherent order, like gender, product brand. We can't order. For example, Apple is a brand, Tesla is a brand, Pepsi is a brand, and Comba is a brand. And right, so there are different brands. So it has no numerical values. So these are the labels. These are label. These are categories. Categories. Brand is a category. Brand is a categorical variable. Name is a categorical variable. We can't order. We can order names. We can order brands. We can write the uh, the foods. We can write. We can categorize type of food, but we can order the preferences. But we can order the, the labels. So we use just to classify the color. Right? Say color. Color is what? The color is categorical, not ordinal. You say red, blue, green. So these are the classes, right? These are the categories of some type classes. We can't order it. We cannot say red is superior than black, black is superior than white, yellow is superior than green. No, we cannot say. We can, right? We can put labels. That those type of data is called nominal data. Categories without inherent order. It has no order. For example, gender, product brand. And the second level, ordinal data. Order. First rank, rank. First rank, second rank, third rank. And very good, good, bad, very bad. It has an order. Qualification, uh, qualifications, primary, secondary, O level, A level, certificate, diploma, degree, post degree, postgraduate diploma, master, PhD. Right? So it has what? It has order. Ordinal data, eh, even it has no numerical values. Categories with specific order. It has a specific order, but unequal intervals. I will explain in the next slide. What does it mean? Unequal intervals. Satisfaction level. I like very much. I like very much. I like neutral. I dislike. I dislike very much. These are what? These are the orders. And now we look at look at the quantitative data. Quantitative. Also, it has two types. Two types. One is discrete data. As I explained you, this is a full numbers, full number, whole number, whole number. And that's one type. The second type, continuous data. Continuous mean, right, the measurable, like kilogram, weight, height, like that. So the first one, discrete data. So these are countable whole numbers, example number of employees. And continuous data, measurable, right here, measurable values within the range. Example, sales value, the range 1 to 5, it takes any value. So that is continuous data. Let's see the summary of the qualitative data and the quantitative data. First, the nature of data. Qualitative describe the characteristic. It describes the characteristics or attributes. A quantitative data is numerically measurable. Subcategories, it has first nominal data and ordinal data. Nominal data, it has no order, but they have label. Ordinal, we can order based on some logic. That is ordinal data. Discrete data is a full number. Continuous is it take full number plus what do you call fractional values. The method of analysis, we can use the frequency table. So frequency table means how many gender, how many males, how many females, how many black, how many white. How many green? How many mangoes? How many apple? How many banana? And the proportion. What's the percentage of male? Percentage of female? Percentage of happy customer? Percentage of healthy individuals? Bar chart. To display this, we can use the bar chart. Like bar chart is like this. It's a column chart. Sometimes we call column chart. So here, a red, blue, green. Yeah, we can put the count 10, 15, 12, right? So we can use this kind of visualization. And for the qualitative data, we can use mean, right? Mean, average. Mean, average. We can use histogram. We can use t-statistics, t-test, regression analysis, correlation analysis, hypothesis test. We can. Level of precision, level of the accuracy. Precision means the accuracy of data types. The measurement, called the level of measurement. Level of measurement. It has four level of scale of measurement. First level, nominal data, nominal scale. Number two, ordinal scale. Number three, interval scale. Number four, ratio scale. So it has a level, right? The first level, second level, third level, and this fourth level. Right. Nominal data, as I explained you, nominal data include only what you call the categories, right? It has categories like the name, color, gender, like this, city, country, brand. So it has no order. Simple categories. These are the categories without any inherent order. It has no inherent order without any inherent order. For example, labels or names based on Kumara, Ratnasiri, Vasanta, Pereira, Nimal, right? So these are these are names. We can't give any value. We can't order these names. Examples, payment method, credit card, credit payment, debit card, cash payment. The categories. We cannot say credit card is uh, better than, no, it's been the type, right? The type. And the product type like large product, small product, very small product, electronic product, home appliances, sports, outdoor. So these are product types. So what kind of analysis we can do? Frequency count, and mod. This the thing we can do. Mod mean how a particular occurrence repeated several times, most of the times. That is mod. We'll study in the forthcoming lectures, hopefully. And second level, this is ordinal data. Ordinal is coming, and so these level 1 and 2. These level 1 and 2, the nominal scale and the ordinal scales coming under qualitative. Qualitative. These 3 and 4 is coming under quantitative data. Right. Ordinal data, ordinal scale, ordinal categories, right? So these are the categories with a specific meaningful order. It has a meaningful order. For example, first rank, second rank, third rank. But unequal, right? The very important term, unequal or unknown intervals. between values. But when you look at here, the ordered value with equal interval, here equal interval, also here equal interval. But here, the difference here, main difference. The ordinal scale, right? Ordinal, it has no equal gap between the levels. For example, I could say the class, the marks, the student exam marks, the exam marks. Ravi, Kumar, Nimal, right? Ravi, Kumar, Nimal. Ravi obtained 72, Kumar 89, and Nimal is 94. Sorry, 99. 99. 99. Who is rank number one? Nimal, Kumar, or Ravi? Who is rank number one? It's your time.
Nimal.
Very good. Nimal, rank number one. Rank number two?
Kumar.
Rank two? Kumar, very good. Rank three? Rank three? Who's rank three? Only one or two students are active, right? Ravi, rank three. But here, we can put rank. You see the distance between uh, rank 1 and 2, the differences, marks difference,
10. 10.
10, very good, 10. A difference between 3 and 2, 2 and 3, how many? 17. How many? 17. 17. We assume one more person, Dharmasene, right? Dharmasene, he got, uh, he got, say, 71. Dharmasene got 71. The rank would be 4. The difference between rank 3 and 4, only 1. Yes, only 1. You see, right, we can tabulate rank 1, 2, 3, 4. The difference, first 1 and 2, they have 10 marks, 2 and 3, 16, sorry, 17, and 3 and 4, 1. So the intervals, right? The intervals between the ranks are not equal. Right? Likewise, the good and very good. Here, very good, normal, bad, very bad. It's easy. It is very easy to take normal to good, right? So look at students. Students. So they have right. They have the exam. They could fail, right? Fail or yes, C, D, A plus. It's very easy to bring a student from fail to S pass, simple pass, right? And also, so for that, the training, we require training, say 50 hours. We need 50 hours to bring a student from fail to yes. And to bring a student to bring S to C class, right? C, he need additionally 60 hours, right? Additionally 60 hours, 60 hours. And from C to B, again, he have to work hard more. And it's very hard, right? This is easy. And S to C, it's harder than this, right? And jumping C to B grade, it's harder than this. And B to A is very hard, right? Very harder than C to B. And now A to A plus is very, very hard. The intervals are not equal. Intervals are not equal. It's very, very hard, right? Very good to excellent. Very hard. So the intervals are unequal. That's a thing here I want to emphasize. Here, you see, categories with a specific and meaningful order. It has a meaningful order, but unequal, or unknown interval. Unknown interval in the race, right? In the race. So this is the final line. You say triangle number 1, 2, 3. You see the differences. See here, this gap is very high. You see here between 1 and 2. Oh, these are the orders 1 and 2. The differences, the intervals are unequal and unknown intervals between the values. Example, satisfaction level, poor, fair, good, excellent. Right? Poor is better than fair. Fair is, sorry, yeah. The fair is better than poor. Good is better than fair. Excellent is better than good. But we don't know the distance between them. What kind of analysis we can do is median analysis. Median, the central point. Median is a central point and percentile. And now we move little advance of this interval scale. Interval scale. Here in the ordinal scale, the differences between one and intervals are not equal. Not equal. Not equal. But here, the differences between the intervals are equal. So interval scale mean it adds equal intervals on the data. Here, characteristics. Ordered values. Here also order. Here it is ordered. So ordered values with equal and meaningful intervals. Meaningful intervals. But the point is here no true 0 point. No true 0 point. For example, the room temperature. So what are the measures we can use to measure the temperature? What are the measures you know? What are the measures we can use to measure temperature? What are the measures you know? I know Celsius. Celsius. And what do you? Very good. Fahrenheit. Fahrenheit. What else? What else? Kelvin. Right. Now the normally room temperature. Room temperature in our country we have 34 or 35 Celsius. Celsius. Some countries, when you look at the fridge, the temperature it may go up to 0 Celsius. What do you mean by 0 Celsius? 0 Celsius mean? Can you say, there is no temperature, no heat? Can you say no heat in the particular place? Is it meaning to say there is no heat in the particular place? Say Iceland or Greenland, very famous now. Greenland, someone say the temperature of Greenland is 0 Celsius. What does it mean? No temperature. No temperature. There's no temperature. Can you say like that? Can you say? You can't say. Why? If we use Fahrenheit, it could say 28 or some 32 or something. 0 Celsius equal 32 Fahrenheit. So we couldn't say. If we use Kelvin, it may show 2557 or something, right? I'm not sure. Like this, right? So it has no zero. It has no zero, no true zero. Zero here in the Celsius we have zero, but it has no true zero. So that kind of data is called what? It's called interval data. And also here temperature. Now the temperature is 10 Celsius. It's become 20 Celsius. When you look at the scale, the temperature scale, thermometer, you can see clear-cut intervals. Clear-cut here, 5, 10, 15, 20, 25, 30, like that. Look at here, 10, 20. The intervals are equal or not? Interval equal or not? Yeah, intervals are equal. Intervals are equal. But, right, one point is very important here. You can say, right, the intervals are equal, but when someone say 10% yesterday temperature 10, today temperature 20 Celsius, it is technically incorrect. It's technically incorrect to say that today temperature is twice than yesterday. 10 and say the boil, right? A particular substance boiled earlier 50 degrees Celsius, now 100 Celsius. The temperature. We cannot say it's double than this. We cannot say. Physics, when you study in physics, you can understand what is it. But this class is not physics class, no? Right. Here, the temperature in Celsius, the difference between 10 Celsius and 20 Celsius is the same as 20 and 30. The intervals are same, but 20 degrees Celsius is not twice as hot as 10. We cannot say, right? We cannot say 20 degrees Celsius is not twice as hot as 10 degrees Celsius. In our field, in business field, it's this kind of scales are seldom we use, rarely we use. Right? Not seldom, right? Very rarely we use. Mean Standard deviation, addition, and subtraction. Right? We cannot, so we can use this kind of analysis. In your day-to-day life, you may not encounter this kind of data since you are social science students. But if you are in physics, chemistry, biology, this kind of data may be more useful for them. And most of the time, they are dealing with this. And next level of data is ratio data. Normally, we use this kind of data. A business, we use this kind of data. The thing is, it has true zero. It has true zero. For example, sales. Sales equals zero. It means what? No sales. Production equals zero. It's true zero. It has true zero. It means no product. No product sold or produced. Ratio, it's called ratio scale, the next level. It's the advanced level. It has two zero. It has two zero. The characteristics, ordered values, ordered values with equal intervals. You see, it has equal interval and true zero, true meaningful 0 point. Allows for ratio comparison. Ratio mean, as I told you, here 10 Celsius and 20 Celsius. We cannot say twice, double. No. Here it is possible. Say last month sales 50,000, this month sales 100,000. So we can say that this month sales is twice than last month sales. It's possible. It's meaningful. It's meaningful comparison. Or last month sales is half of today's sales. Example, sales revenue 100,000 is twice 50,000 rupees or dollar. The weight 20 kilogram is twice as heavy as 10 kilograms. What are the analysis we can do? We can do all available analysis in statistics. All mathematical operations are meaningful for this analysis, for this kind of data. Yes. Population and sample. Population and sample. In the first class, we have discussed in detail what is population and sample. I helped, right, to explain this. I used an example is what the blood, human body blood, right? 6 liters blood into 5 ml blood for a medical test. So population means entire group, right? They are all blood in the body. Entire group, it says entire group. Sample, this 5 ml sample, representative subset of population. Subset of population. By definition, the complete set of all elements, or units relevant to a study. Definition of the population mean a complete set, full set, a full observation, all observation without missing any case. The complete set of all elements or units relevant to a study. So if you are going to study the blood, all 5 liters blood is your population. If you are going to study the attitude of the student, university students, then all university students are your population. Or if you are going to study uh, class attendance of first year students of Southeastern University of Sri Lanka at the Faculty of Management, a Department of Commerce, then a particular, right? Commerce students, FMC, and SUSL. If you are going to investigate on that, so all commerce first year students are your population. So that's why the relevant to study is very important. The term relevant to study. Right? Study mean investigation. Investigation. All employees, all employees of a company, all product manufactured in the factory, all employees. And if you are going to study employees in their John Keel's holding, John Keel's, then each and every employees within that company is your population. Anchor is producing milk packet, all milk packets produced by that particular company, right? And this is it's a population. Characteristics provide a complete accuracy, but is often impractical due to high cost, time, and resource constraint. Is it possible to investigate all the product produced by the company? Is it possible to study all employees of a particular organization? Is it possible to test all 6 liters of blood in your body? No, right? Still sample the subset of population. That is sample. Sample is a representative subset. So definition, a subset of population, selected for study. Subset is very important. The term subset is very important. Examples, 100 employees selected from a company where 5,000 or 6,000 employees are working. You choose only 100 employees. 50 product selected for quality testing, but it produces millions of product, thousands of product. Characteristics, efficient, right? It's efficient and cost effective, used to make inferences about the entire population. You may heard this term in the first class, inferences. The doctor, right, based on your report, blood sample report, he inference his conclusion to entire body, sick or not. He comes to the conclusion based on the report, test report, sample test report. See the differences in nutshell. The population and the sample. Here, aspect definition. So population means complete set, sample is a subset. Size, very large size, very large and small and manageable. Cost, high cost to collect data from the population, low cost to collect data from the sample. We need more time to manage the population data. So less time enough to manage sample data. Accuracy, right? We can take complete accuracy when we deal with complete data set population. And the sample, it is estimated accuracy. Accuracy is estimated. Now the sampling. How do we select sample? How do we select sample? Right. Art of selection and overview of sampling methods. You know what is sampling? Sample simply the subset of population, that is sampling. Right. How do we select the elements within the sample? How do we select elements? Mainly, there are two methods. One is probability sampling. Number two, non-probability sampling. Probability means the chance, right? The chance. And non-probability mean purposefully, or when you toss a coin, head or tail, right? You may get head or tail based, it is based on your chance. That's called probability. And probability sampling method, sometimes we call as a random sampling, random selection. We don't know which one is going to be selected. The core principle is every element in the population has non-probability of being selected in the population. In the population, in the Mahajana Sampata lottery, you can see the nine balls in a basket, in a bowl. It is randomly selected. It will be randomly selected. We don't know which number is going to be selected, but each ball is having equal chances. So that is the main principle. Yeah. Every element in the population has a non-probability of being selected. It allows for statistical inference with measurable sampling error. You know what is statistical inference? And in the future, we will talk about what is sampling error. It is advanced techniques. Measurable, the error, there could be some error, but that errors are measurable. That is the main principle of probability sampling. Within this category, there are four sampling methods under the probability sampling. Number one, simple random sampling. Every element has an equal chance of selection. Example, lottery method. Lottery in a Mahajana Sampata. You can't, right? There are nine balls in each basket. Each ball having chance of getting selected. That is simple random sampling without no classification, just select one. Here in a bag, in a black bag, there are the fruits. You put your hand and pick one. So we don't know which one is going to be selected. So that is simple random sampling. Within the bag, there are apples, mangoes, pineapple, banana, orange. There are many type of fruits in many numbers, in different numbers. You don't know, right? You have given a chance to pick one fruit within the bag. You put your hand and you pick fruit randomly. So that is a simple random sampling. Stratified sampling. Here in the bag there are different fruits. No, apple, two or three apples, 4 or 5 mangoes, 3 to 5 oranges, and 4 or 5 avocado. Right. So there are there are subgroups within the population. The stratified means a grouping, right? First we group apple separately, mango separately, orange separately, and then randomly pick one within a group. That is stratified sampling. Population, right? This is the bag. Assume this is the bag. So this is apple, this is mango, this is orange. First, it should be divided into certain groups. Apple separately, and mango separately, orange separately. And then randomly select. randomly select one. That is certified sampling. Population is divided into homogeneous group. Homogeneous mean equal, right? Same, similar characteristics. It's called strata. And random samples are selected from each group. Random sample, right? Randomly selected. Example, sampling from each department to ensure representation. For example, assume that 20 students has to be selected from FMC. In this at this moment, we select first year 5 students, second year 5, third year 5, and first we divide all population into first year, second year, third year, fourth year. That is system number 1. And then first year group randomly select 5 students. Randomly select. And second year randomly select 5. And third year 5, like that. That is right. First we subdivide the whole population into groups, and then we randomly select among them. Cluster sampling. Cluster sampling. Population is divided into clusters. Clusters, for example, geographical area, and entire clusters are randomly selected. Here, uh, in a country, right? In a country, Sri Lanka, it has nine provinces. We're going to study the system effectiveness of government employee effectiveness. So I'm going to do a study, right? So whole population, all government officers, employees are in my population. Then I group them: Northern Province, Southern Province, Western Province, Sabaragamuwa Province, Suwa Province, and then so there are clusters. Each are clusters. Within them, I select only this one. Which one? Say Southern Province, right? Southern Province. I select only employees within this. So this is what? It's a cluster. It's one cluster. I divide all population into 9 clusters. Out of 9, I select 1. Likewise, in the faculty, we have to select 20 students. We have to select 20 students. And what we do is, we select first year, second year, third year, fourth year. Then I select first year. Within them, right? Sorry, not select, right? Whole 100 students. For example, assume that in the faculty, there are 100 students. We need to 20 students. What we do is we divide them according to the districts or according to the field of study, like marketing, HR, in that manner. So I randomly choose marketing. Right, randomly choose marketing. I randomly choose one cluster. So that is what we call cluster sampling. Population is divided into clusters, and entire cluster. Here, this is the thing. Entire cluster are randomly selected for the study. Only one. Pick 1 or 2. So here, it is a population. We cluster based on some of the basis, and we choose clusters randomly. That is clustering sampling. And systematic sampling is selection at a fixed interval. Example, selecting every 10th customer. Or if I want to select 5 students in the class, what I do is I take the attendance sheet. Attendance sheet here is com 001, 02, 3, 4, 5, like that, the numbers. What I do is I select every 5th one, com 5th. First I select com 5th, this one, Then 1, 2, 3, 4, 5, 6, 7. And right. Then 10. 10. Next, 15. Next, 20. Next, 35. Next, 40. So if anybody asks, how did you select? I select I select in systematic manner. What is your system? I take this attendance sheet. I select each fifth student. Each fifth student. So that is what? That is systematic sampling. Systematic sampling. So that's all about probability sampling. Now we talk about non-probability sampling. It is not based on the chance. It is based on the purpose. It is based on the convenience, purposely. It has bias, right? It's bias, sometimes unfair. Bias, sometimes unfair for some people, right? And the non-probability sampling method is called non-random sampling, non-random selection. The core principle is selection, right? Selection is not based on the known probabilities, not based on known probabilities. Useful for exploratory studies, but formal inferences is limited. Formal inference, we cannot generalize to all. For example, national competition, we need to send some student in our faculty from our faculty to a national competition like football competition, national football competition, inter-university football competition. We cannot randomly choose from our faculty. We cannot choose students randomly. What we do is we have to search, we have to find students who are actively engaged in football. We purposefully select students. We select 12 to 15 students to participate with the football match. Same thing, for example, quiz competition, right? Quiz competition, commerce quiz competition. Here, if I want to select students, what I do, I looking for students who are most intelligent in the class, most intelligent in the class. So I select them, purposefully I select them, and I send the quiz. This is not random, right? This is based on the purpose. Sometimes convenience, convenient. So I want to, for a workshop, right? For a workshop to be held in BMICH, the organizing team requested me to send 5 students to participate in the workshop. What I do is, I select 5 students who are very much reachable to me, or who are in contact with me. It's a convenience analysis. So I selected the candidate students based on my convenient, So that's called convenient sampling. Convenient sampling, right? The selection is not based on the known probabilities, right? Here, this is useful for exploratory studies, formal information. Right. First, there are 2 types. One is convenient sampling. Convenient sampling. Selection of the most easily accessible elements. Accessible element more easily. This right. Purposive sampling. Second method. Purposive sampling. I choose the one or I choose a few purposefully. For example, for football match, for quiz competition, I purposefully select certain candidates for purpose. When I selecting the sample, I have purpose. Selection based on characteristics or on expert judgment. So I'm an expert. I teach this class. Some students are very active. So I know them. They are they are good in such a manner so that I can recommend them. I can select them. So that is purpose sampling. The making the leap, the power of statistical inferences, statistical inference. As I uh, told you earlier in the blood test, 6 liters of blood, we take 5 ml a sample. This sample will be undergo for testing, and the test result will be used to generalize the finding to the whole population. So that is called inference, statistical inference. Let's see. Central concept, important concept here. Statistical inference is the process of drawing conclusion about a population from the sample data. Drawing conclusion about population from sample data. Right here, the sample data, based on sample blood, we do inferences, come to the conclusion. First, what we do, population, we define the population. Population mean what? The entire group of interest in my study. Population, we select few of them in any way of sampling method, maybe probability sampling or non-probability sampling, and systematic sampling or convenience sampling. So whatever the method, I choose the sample. A sample should be a representative subset of as a representative subset is selected. For example, here Mr. A, right? A approach a doctor for some sort of like for seeking some remedies for his sick. Mr. A. Doctor advised him to take a blood test, and he approached an MLT, medical laboratory technician. He requests 5 ml blood, 5 ml blood sample. What he do is, he is not ready to give blood, and he asked Mr. B, he invites Mr. B. B is his friend. B is his friend, and Mr. B goes to the MLT and give 5 ml blood. 5 ml blood. And the MLT give a report, prepared report based on that 5 ml, this 5 ml, B 5 ml. And this report is taken by A. A goes to the doctor. And doctor will read the report and give medicine to A. Is it right? Is it right? The doctor decision is right? Right or wrong? It's your time. The doctor's conclusion about this patient A is right or wrong? It's right or wrong? It's your time.
Wrong.
Wrong. Why it is wrong? Why? He has the report, test report. Based on the test report, doctor give medicine to him. Then why is wrong? Why it is wrong? Why it is wrong? Can you see my screen or not? Oh, now only you can see, no? Okay. Tell me why it is wrong. Why it is wrong? Right? A is the patient. A is the patient. He approached doctor to take some medicines for his sickness, and doctor advised him to take blood test, and uh, A approached MLT. MLT request 5 ml blood. For the in that instance, A got fear, and he requests his friend Mr. B, and he bring Mr. B to the lab, and Mr. B give 5 ml blood for A, and MLT take that blood, and he prepared a report, right? Report, and this report this report is taken by Mr. A, and A is given this report to the doctor, and doctor read this report, and based on this report, based on the report, doctor give medicine to A. Is it is the medicine is correct or not for him? The medicine is correct or not? Is it suitable or not to Sir A?
Not suitable.
Right. Why is that?
Because that blood report
Yes,
is B1.
very good. The thing is, right, the sample should be representative. So this 5 ml blood should be represent population. A's blood. But actually, this 5 ml, the MLT taken, the report, based on the analysis of 5 ml blood of Mr. B, right? And Mr. A argues, claims that this report belongs to A, and doctor infer that sample statistics, right? The analytics to the infer to Mr. A. It is wrong because sampling error, because the 5 ml is not a representative subset. It's not representative subset of the population, right? So it's very important. It should be representative. Next, right? Next, the sample, right? Do the data analysis. This is 6 liters blood, and from 6 liters, he take 5 ml, and the MLT do the analysis, right? Analysis. This is called sample statistics. Sample statistic. He may do, sorry, he may do blood count, WBC, RBC, sugar level, right, cholesterol level, everything he will test, right? And this test is what? This is a data analysis, and he prepared this. He summarized this report in a document, in a what do you call, in a report, and then the summary will be used to generalize the finding to the population. Who is the population? This is the population. Population parameters. Inferences are made about the population. Inferences are made about the population based on the sample. He make conclusion, generalize the finding to the population, mean population proportion, right? So there are a lot of analysis we can do. We'll discuss in the coming sessions. Population parameters. Population parameters. The key concepts in the inference process. First, there are the point estimation, interval estimation, hypothesis testing. Point estimation. Using a single value from a sample to estimate the population parameter. Population parameter. Right. So when I ask somebody of you, so it is not about the inferences, right? So just general question. In an IQ test, how many? What could be your score? Please randomly, someone please randomly, can you tell me? So if I do an IQ test, how many marks you may take? What's your score? Someone could say 70. Right? He tell only one, right? 1 point. So this is called point estimation. Interval estimation. Someone say, right, I may score 65 to 75. I will score from 65 to 75. So here he gives, right, an interval. He may take the score between this, sometimes 65, 67, 70, 77, sorry, 73, 74. Maximum he may take 75, minimum 65. So within this range, he may score. If we come to the conclusion in this manner, it is called interval estimation. Interval estimation. So it has confidence intervals. 95. I believe, 95% chance, right? I believe 95% chance that I may take the score 65 to 75. I may score, the score will be 60 to 75. That is interval estimation. Point estimation here, how much marks you may get, or the score, IQ score you may get. He said, yes, 70, I will get 70. So we could less accurate, no? Less accurate. That's called point. He indicate 1 point. Point estimation using a single value, from a sample to estimate population parameter, right? Population parameter. Say, for example, in the class, I ask a height of the students. I want to test height of the students in the first year, right? First year height of the students. Then I pick few number of students. Say I select 50 students from that population, and I measure the height. And I found that the average height is 170 centimeter. If I say all first year students, right now, based on the sample, I infer to the whole population, Sri Lankan State University students' height. The Sri Lankan State University students' height is 170 centimeter. If I climb in this way, this is point estimation. I use only a single number. Rather than using a single value, if I use the university student, first year student's height is between 160 to 180 centimeter. So this is what we use, two values with confidence. So it is called interval estimation. Based on the sample, I predict the population. So point estimation, using a single value from a sample to estimate population parameter. An interval estimation, providing a range values that is likely to contain the population parameter. Same, right? So, but we use to a range. Hypothesis testing, a formal procedure to test a specific claim or assumption about the population. We guess as hypothesis, we guessing, right? We guess hypothesis test. So somebody may ask, somebody come and say the average height of the students of first year State University Sri Lanka is 150 centimeters. Someone asked. So we have to prove them. whether his guess, his claim is correct or not. His claim is correct or not. Then what we do, from the population, we select sample and we collect data and we do analysis. Based on the analysis, we compare the claim, the argument, and the actual result. So that is what hypothesis testing. We will study in detail in coming lectures. From theory to impact. So business statistics in business management. When and how we use this kind of where we can use statistics in business. We can use in strategic planning. Like strategic planning, you might see planning, right? In planning stage. Say for example, the retail chain like Cargill's Food City or Kiel's Super retail chain analyze regional sales data to optimize inventory and meet local demand. So the Cargill's Food City in the country, it located. It's located in major cities of the country. Then some region, some stores, some items are move fast. Some regions it not move. So keeping inventory unnecessary causes additional cost. And the slow moving, right, the fast moving item, we keep less inventory, it causes loss of customer. So that when we do collect data, analyze data about the store sales, then it's easy to make planning, optimize inventory management, quality control and improvement. Quality, so Anchor milk powder, they produce a 400 grams of packet. And sometimes it's may more than 400, sometimes less than 400. Then it's may quality issue. And sometimes it's may got position. So that we use a sampling method and they test the qualities. And forecasting, you can take the past figure, say stock price data, and take the past figures and you can estimate the future forecast, future prices. Consumer behavior analysis, how a customer select a particular product or how a particular customer buy a product, how a particular visitor, you may use Temu and you may use Daras, then it will trace you how often you visit and how long you are stay in the application and how much you are spending. So that kind of data they will collect from you and do the product recommendation for your app. And market analysis and trend, so which product is going faster, which product demands going down. That kind of analysis can be used. And performance evaluation, employee performance, salesperson performance, and risk management, especially stock market risk management, fire accident, and the insurance companies may use which area, which season, give more risk insurance claims like that. So this kind of uh, analysis can be done using this statistics. These are the examples, few examples of business applications of statistics. Now we come to the last slide, conclusion. We talk about here the core principles. We recap. Statistic is divided into descriptive statistics. This means summarizing what is or what happened, and inferential statistics, predicting what could be happen in the branches. Descriptive statistics and inferential statistics we have studied in the first class. Type of data, qualitative data, quantitative data, and its measurement like nominal data, ordinal data, interval data, ratio data, and dictate the appropriate statistical method. We study samples to make educated cost-effective inferences, representative sample about entire population, and every major business functions from marketing and finance to operate HR relies on statistical analysis for optimal business.